So let us take a few question and answers in database and the database management system. So what is database or database management system? That is DBMS. And what's the difference between a file and database? Can file qualify as a database? Now let us see the one by one answer. First is database. So database provides a systematic or organized way of storing, managing and retrieving from collection of logically related information. So logically related information, the way to store them, manage them and retrieve them. The database provides a systematic and organized way of doing this. Secondly, the information has to be persistent. That means even after the application is closed, the information should be there or persisting. Then final, it should provide an independent way of accessing data and should not be dependent on the application to access the information. So when we talk about the file and database, the main difference between a simple file and database, that database has independent way, that is certain way of accessing information, while simple file do not. The file meets, of course, a file meets the storing, managing and retrieving part of the database, but but not the independent way of accessing the data. And many experienced programmers think that the difference is that file cannot provide multi-user capabilities which DBMS provides. But if you go to COBOL and C programs where files were the only means of storing data, we can see functionalities like locking, multi-user, etc. provided very efficiently. So it's a matter of debate. Of course, if some interviewers think this is the main difference between the files and database, accept it. Going into the debate is probably losing a job, of course, because these are the interview questions. But we can answer like this at the present juncture, that these files cannot or do not qualify as database. Okay, does this do? And yes, the file does qualify as a database, but not as a database management system. So you can always say that files and database are equivalent, but there are certain ways of accessing the database. Then the file can be termed as a database. What is SQL? Structured Query Language. SQL stands for Structured Query Language. It's a ANSI standard, American National Standard Institute standard for computer language. This is for accessing and manipulating database systems. Accessing and manipulating the database system. So SQL statements are used to retrieve and update data in a database. SQL is made from certain languages specifically organized and tailored for database activity. For example, you might have heard about QUEL. SQL is made from these languages and specifically for database purposes. Next is what is difference between DBMS and RDBMS. DBMS and RDBMS. See, DBMS provides a systematic and organized way of storing, managing and retrieving from collection of logically related information that we have just seen in the previous question. RDBMS also provides what DBMS is providing. But above that, it provides the referential integrity. So in short way, if you add DBMS with the referential integrity, then we term it as RDBMS. Why this DBMS is RDBMS? R is relational database management system. So it follows certain relational calculus aspect, relational algebra aspect. So we are adding the referential integrity to the DBMS. So these relations or tables are defined by using, say, foreign keys in any RDBMS. Many DBMS companies claim their DBMS product was RDBMS compliant, but according to industry rule and regulation, if the DBMS fulfills the 12 chord rules, it's truly an RDBMS. So there are 12 chord rules that needs to be seen. So almost all DBMS, SQL Server, Oracle, they fulfill the 12 chord rules and they are considered as truly RDBMS. So we have just indicated or introduced the RDBMS we say the RDBMS when we have these 12 chord rules to be followed. So let us see these rules. What are these chord rules? They are, in 1969, the great Dr. E.F. Codd, he laid down 12 rules which a DBMS should adhere or conform in order to get the logo of true RDBMS. So what these are? First is the information rule. What it means is, Rule 1 is the information rule. All information in a relational database is represented explicitly at the logical level and in exactly one way by values of table. Second rule is the guaranteed access rule. What does this mean? Each and every datum, that is the atomic value in a relational database, is guaranteed to be logically accessible by resorting to a combination of table name, primary key value, and the column name. What happens in flat files? We have to parse and know exact location of field values. But if a DBMS is actually or truly a RDBMS, we can access the value by just specifying the table name, the field name for just instance customers, like field customer name, you'll get the customer name. Then the rule 3 says systematic treatment of null values. Systematic treatment of null values. What it says is null values which is distinct from the empty character string or a string of blank character or string from 0 or any other. Please understand, null values are not these are not these. So they are distinct. Their null values are different. The empty character string or a string of blank character or a 0 or any other number is different from null values. So these are null values are supported in fully relational DBMS or representing missing information and inapplicable information in a systematic way. So this is independent of data type. Rule 4 says the COD rule 4, that is the dynamic online catalog based on the relational model. Dynamic online catalog based on relational model. So the database description is represented at the logical level in the same way as ordinary data. So the authorized user can apply the same relational language to its interrogation as they apply to the regular data. So the data dictionary is held within the RDBMS, thus there is no need for offline volumes to tell you the structure of the database. Next, the rule 5 is comprehensive data sub-language rule. So a relational system, RDBMS, may support several languages and various modes of terminal use, for example, fill the blanks mode. However, there must be at least one language whose statements are expressible for some well-defined syntax as character strings, and that is comprehensively supporting all the following items like data definition, view definition, data manipulation, and integrity, constraint, authorization, transaction boundaries like begin, commit, and rollback. Rule 6 says, that is view updating rule. All views that are theoretically updatable are also updatable by the system. This is view updating rule. Next is rule 7 is high level insert, update, and deletion. The capability of handling a base relation or a derived relation as a single operand applies not only to the retrieval of data but also to the insertion, update, and deletion of data. Rule 8 says physical data independence, means application programs and terminal activities remain logically unimpaired whenever any changes are made in either storage representation or access methods. Then we have rule 9, which is the logical data independence. It says that application programs and terminal activities remain logically unimpaired when information preserving changes of any kind that theoretically permit unimpairment are made to the base tables. Next is the integrity independence. Integrity constraints specific to a particular relational database must be defined in the relational data sublanguage and storable in the catalog, not in the application programs. While rule 11 says distribution independence, a relational database has distribution independence. Then the final rule of Dr. Cod for RDBMS is non-subversion rule. Non-subversion rule says if a relation system has low level, that is single record at a time language, that low level cannot be used to subvert or bypass the integrity rules and constraints expressed in the higher relational language, that is multiple records at a time. Now the next question is, what is ER diagrams? What do we mean by ER, or entity relationship diagram? ER diagrams, also known as entity relationship diagrams, this shows relationship between various tables in the database. The entity and their relationship. Entities have various attributes also. So we are talking about a table in which various columns are there. These columns are the attributes. So entities have their attributes and there are various entities, how they are related. This is entity relationship diagram. This ER diagram shows just that. Now next is how many types of relationship exist in database designing. So we have three major relationship models: one-to-one, one-to-many, and many-to-many. this kind of relationship. Okay. Next is what is normalization and what are different type of normalization. See, normalization in normal terms, normalization is decomposing the table to maintain the consistency and redundancy, to remove the redundancy. Sorry. So there is a set of rules that has been established to aid the design of table that are meant to be corrected through relationship. So this set of rules are known as normalization. So the benefits of normalization, normalizing your database is basically avoiding repetitive entries, reducing required storage space, and preventing the need to restructure existing table to accommodate new data, and increase the speed and flexibility of queries and sorts and summaries. So for these are various normal forms. They are normal forms till 5NF, and they are PGNF. Domain constraint also has a normal form. So let us take the first normal form. For a table to be in first normal form, data must be broken up into smallest possible. Smallest, because in addition to breaking data up into the smallest meaningful values, table first normal form should contain the repetition group of, or should not contain the repetition group of fields. Then here's the second normal form. The second normal form states that each field in a multiple field primary key table must be directly related to the entire primary key. Or in other terms, each non-key field should be a fact about all the fields in the primary key. Third normal form. A non-key field should not depend on another non-key field. A non-key field should not depend on another non-key field. What is denormalization then? Denormalization. Denormalization is the process of putting one fact in numerous places. That is, it's vice versa of opposite of your normalization. So only one valid reason exists for denormalizing a relational design to enhance the performance. And the sacrifice to performance is that you increase the redundancy in the database. Now the next is, can you explain fourth normal form and fifth normal form? These are related to the multi-valued dependencies. So in fourth normal form, it should not contain two or more independent multi-values about an entity and should satisfy the third normal form. And the fifth normal form, it deals with reconstructing information from smaller piece of information. So these smaller pieces of information can be maintained with less redundancy. Then have you heard about the sixth normal form? Do you know sixth normal form? If you want relational system in conjunction with time, we use sixth normal form. So relation system in conjunction with the time, we use sixth normal form. At this moment, SQL Server does not support it directly. Next is what are DML and DDL statement: data manipulation language and data definition language. So DML stands for data manipulation language. They update data values in table. They manipulate. Below these are the DDL statement like select or update. So select gets data from the database table, update data in a table. So deletes data from a database table, and insert new data into the database table. DDL, data definition language. This stands for data definition language. So they change structure of the database object like table, index, etc. So most important DDL statements are like this: create table, which creates a new table in the database; alter table, that changes the table structure in the database; and drop table, this deletes a table from the database; and create index, that creates an index; drop index, this deletes an index. How do we select distinct value from a table? Distinct. Why distinct? Because you want to remove the repetitions. So distinct keyword is used to return only distinct values. So we have a, say, in syntax like this, column age and column table like this one. So select distinct age from this table. So select age from this table, which is the PCDS EMP. So we use this distinct after select. Next is what is a like operator for what are wildcards. Now if you want to matching something, and you want to take the result out of it, of a matching condition, of a matching string, of a matching wildcard. So we use this like and wildcard. So like operator is used to match patterns. So this is for pattern matching. For example, a percent sign, you have percent and you have underscore. This percent sign is used to define the pattern. We have SQL statement will that will return all words with the letter S. For example, select star from say this employee, where employee name like S%. So S along with all the names which starts from S. So we have one more statement that will return all words which end with the S. So select star from this employee, where employee name like %S. So all those prefixes which ends with S, all those names will come. Then we have one more SQL statement that will return all words that is having letter S in between. So select star from some table where employee name is like percent here, percent has S between. That means it will give all the names which contains S, which contains S. So the underscore operator is also there. We can read this as underscore operator. So this underscore operator is the character defined at that point. So only this is a single character matching. So we have a sample query like select name from this employee where name like underscore S. So this will give all the names where second letter is S. First and second letter is S. Okay. Can you explain the insert, update and delete query? Insert, update and delete query. Insert statement is used to insert new rows into the table. Insert element is used to insert new rows in the element. Update to update existing data in the table, and delete statement to delete a record from the table. Deleting a record from the table. So we have certain code snippet to insert, update and delete. So this is insert into say some table. Set name equal to some name and age equal to some number. And this is the update one. Update the table. Set age equal to 25 where name equal to some name. And also delete from this table where name is equal to some name. What is order by clause? Order by clause. Ordering, you know what ordering is? Ascending, descending. So order by clause helps to sort the data in either ascending order or descending order. Ascending order sort query, like this select name from and age from this employee or this table. Order by age. Now the result will be in the ascending order with respect to the age. Yes, and descending order. What about descending order? Order sort query. We have to use order by DSC. Order by age, DSC. What is the SQL in clause, and can you explain the between clause? So we'll see these two questions. So SQL in clause, SQL in. This in operator is used to see if the value exists in a group of values. If the value exists in a group of values. For instance, the SQL, this query, checks if the name is either Rohit or Anuradha. So select star from this table where name in. So it will check between whether it is Rohit or Anuradha. Also, you can specify a not clause. So not in also can be used with the same. Select star from say PC DS employee when age not in 1760. These are the numbers. So the number should not be 1760. Can you explain the between clause? Between clause. We'll see SQL which selects employee born between. So if you want to find out or result of a query is somewhere between two values like these two dates, as per MySQL, what can we use? Select star from this table where DOB, date of birth, between, we use between here, these two ranges. So for a range, you want to find a value between range, then you can use this between clause. We have an employee salary table. How do we find the second highest from it? How are you going to do it? For that, will you be using this aggregate functions like sum, count, all this? But we can do it like this. We have a SQL query which find the second highest salary. Select star from this table where 2 is equal to select count. Now we are counting. That is why I've said that we are using this aggregate function. Select count distinct B salary from again the table where B salary is greater than A salary. So you are finding the topmost and then again the next one which is less than this. So this is how this query works. What are different types of joins in SQL? There are various joins. Joining is combining the two tables. What are the ways of combining various tables? Because what you have done in normalization, you have made tables, different tables. And now what you are trying to do is, you are trying to combine them. So let us see inner join. Inner join shows matches only when they exist in both the tables. Inner join means both the tables. And example we see in SQL, there are two tables. One is your customer and one is your order. and the inner join is made on the customers. So customer.customer ID, orders.customer ID. So this SQL will only give you result with the customer who have orders. So if the customer does not or do not have order, it will not display the record. So like this, the query goes like this: select customer.star from order.star. From customer inner join, orders on customer.customer ID is equal to orders.customer ID. Next is the left outer join. What it gives? Left outer join. The left join will display all records in left table of the SQL statement. So in SQL we'll see a query: customers with or without orders will be displayed. So order data for customer without order appears as null values. For instance, you want to determine the amount ordered by each customer, and you need to see who has not ordered anything as well. For this, you can also see the left outer join as a mirror image of the right outer join. This is covered. We'll see it if you switch the side of each table. So we'll use select customer.star order.star from customer left outer join orders on customers.customer ID is equal to orders.customer ID. Then we have right outer join. So right outer join will display all records in the right table of the statement, SQL statement. So in SQL, we'll see we have a query. Below, all orders with or without matching customer records will be displayed. Customer data for orders without customers appear as null values. For instance, you want to determine if there are any orders in the data with undefined customer ID value, say after a conversion or something like this. So you can also see the right outer join as a mirror image of left outer join if you see the side of each table. Like select customer.star from order.star from customer's right outer join orders on customers.customer ID is equal to orders.customer ID. So this is the first installment of the DBMS questions. We'll see one more session of this. Thank you so much.